I just looked at my notes again and I realized in the last video I should have mentioned one more point, and that has to do with isomers. So we have all these I words, you know, and so an isomer is a chemical that has a whole lot of atoms in it. And so when we were talking about water, or H2O, or oxygen, O2, oxygen gas, or carbon dioxide, CO2, there's so few atoms there that you can only put them together in one way. But if you talk about something like a sugar, and the formula for that is C6H12O6. And remember what I said, that means you've got 6 carbons, 12 hydrogens, 6 oxygens. Well, you can just imagine if this was Legos, you could put that together in a lot of different ways. And even in nature, though, that chemical formula can be put together in 3 different ways. And so the different forms, the different structures, the way that's put together are what we would call isomers. And it ends up that those sugars, those isomers of the C6H12O6 have their own names. And it's glucose, fructose, and galactose. Those 3 chemicals are isomers. Now, there are isomers, a lot of other isomers out there, but that's the example we give. All right, so now 2 minutes into this video, we finally get to what I came to talk about, and that has to do with those electrons. And we said, what did we say? Let's review electrons for just a second. We said they're really, really tiny. They are in motion, and they carry different amounts of energy, and they are attracted to the nucleus. And because they have different amounts of energy and an attraction to the nucleus, the distance from the nucleus varies based on the amount of energy. And so how we refer to that is that electron orbits are these distances away from the nucleus that the electrons are circling. So we have different orbits based on the amount of energy that the electrons have. One other point, we said that an atom has the same number of electrons as it has protons. So the atomic number determines the number of electrons that are present. Now, when we talk about these orbits, you can see you have this one here that's really close to the nucleus, only 1,000 kilometers away, but that's relatively close. This is what we would call the lowest energy orbit. Now, the lowest energy orbit gets crowded pretty fast. It only holds 2 electrons. Now, if you move away, out from the nucleus to the next level of energy, this is the higher energy orbits. Well, there's more space in them, so they can hold 8 electrons. Now it ends up, okay, so what I've drawn up here, so I'm going to back away and let you look at my picture for a second. I've drawn an atom that's known as lithium, and I mentioned it a few minutes ago, and I said lithium has an atomic number of 3, so 1, 2, 3 protons, and it has some neutrons. Usually there's 4 of them actually. That's not a heavy isotope, but that's the most common configuration. And as a result of that, it's going to have 3 electrons. So that means we said it can only have 2 of the lowest energy electrons, and one of those electrons has to have more energy. And it's in a higher energy orbit. Now, we said the higher energy orbits will hold 8 electrons. And you're probably at this point saying, well, I don't care. Who cares, right? Well, the atom cares. There is something called the rule of eights. And we're going to use an anthropomorphic term, a sort of a human term, to say that atoms desire a filled orbit, to have filled orbits. And what that means is atoms are not stable until they have a filled orbit. But that leads to a problem, right? How in the heck do you have a filled orbit if you've got 3 electrons? Well, I said before that the atom starts out with that number of electrons. So if you were to ponder that, what do you think can happen to that one electron? So first of all, if wishful thinking, you said, maybe there's some way you could give that away. And what would happen? If you gave that electron away, you'd only have 2 electrons left. And what would you have? A filled inner electron orbit. And that's what the atom wants. So one of the things that an atom can do, especially an atom like this that has 1 electron, and what would be the alternative? To get 7. Well, how on earth are you going to get 7? So that's not going to happen. And then there's another way, but still, there's only really one way that this atom can gain stability, and that's to give away an electron. And so you can't just give it away, you have to give it to somebody. So I want you to look at your notes. On here, let's see if you can see it, this set of notes right here, and you can see that this atom on this side, it's sodium. And if you look carefully at it, you can, I'm sorry, that's not the one I want. Darn it, that is, I need to have chloride on here. So anyway, sorry. So that's sodium. We need chloride. Now, what is chlorine? If we had a diagram, and I'm going to add one to this PowerPoint, you will see that chlorine has 7 outer electron shell electrons. That means it wants 8, but it has 7. There you go. Lithium can give its extra electron to chlorine, and that means chlorine has a filled electron shell and lithium has a filled electron shell. Okay, so woohoo! Everyone's happy, right? But let's think about what is the effect of giving away one of those electrons. And we're going to look at this guy. I'm going to back away and let you look at it. We said that we had positive, 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 negative, negative, negative. It's all equal, right? But if we give away one of those negatives, we've got an extra positive. We'll have 3 positives and 2 negatives. That means this thing will have a charge. Now, if you think the opposite, so now you're going to say, okay, if everything's equal and you give a negative to some other atom, it's negatively charged. What do they always say, like in relationships, human relationships? Opposites attract. In chemistry too. So, and like magnetisms, positive and negative poles come together. And so when we talk about chemical bonding, and we talk about one of those kinds of chemical bonds, which is ionic bonding, I just described it to you. That was ionic bonding. Who knew? You didn't know you were learning about bonding. Now you do. So with ionic bonding, one atom gives an electron away. It becomes positively charged, what we call a cation. And the atom that received the extra negative, the extra electron, becomes negatively charged. We call that an anion. And positives and negatives attract, and they stick together. And what we've produced is a salt. It's lithium chloride. I described how it was produced. Okay, that is one of the major ways that chemicals bond together. I'm going to talk about the other one on the next video.